Welcome to the Module 8 of the Python programming course, Advanced Python, APIs, Automation, and Web Scraping. In this module, we move into the advanced capabilities that distinguish professional Python developers, connecting to online services through APIs, automating repetitive tasks, and extracting data from websites. What you will learn. This module covers 6 key topics. We begin with understanding REST APIs, followed by consuming APIs using the request library. We then cover handling API authentication and JSON data, file system automation scripts, web scraping with Beautiful Soup, and finally scheduling and task automation. Introduction. The Python programmers progress beyond foundational skills. They encounter increasingly powerful capabilities that enable interaction with external systems, automation of complex workflows, and extraction of data from online sources. This module introduces 3 of the most valuable advanced Python skills areas: working with API, writing automation script, and performing web scraping. API are the connective issues of modern software. Every major online services exposes its functionality through REST APIs. Automation scripts eliminate repetitive tasks that consume hours of manual effort. Web scraping extends data gathering capabilities to sources that do not provide formal APIs. Together, these 3 skills, REST API, automation, and web scraping, represent the pillars that take Python programmers from an intermediate to an advanced professional level. Understanding REST API. A REST API, which stands for Representational State Transfer Application Programming Interface, is an interface that allows applications to communicate over the internet using standard HTTP method. APIs accept requests and return structured responses, usually in JSON format. There are 4 primary HTTP methods. GET is used to retrieve data. For example, fetching whether information post is used to send or create data, such as submitting a new student record. PUT is used to update existing data, and delete is used to remove a resource. Every API response includes an HTTP status code that indicates the outcome of the request. Status code in the 200 range indicates success. Code in the 400 range indicates client errors, such as 401 for unauthorized access, 403 forbidden, and 404 for resources not found. Code in the 500 range indicates severe site errors. It is essential to always check the status code before attempting to process a response. Consuming API with the request library. Python request library makes it straightforward to send HTTP requests to API. It is installed using pip and imported at the top of your script. In the first example, we call a public weather API open method passing the latitude and longitude of Kano, Nigeria as query parameters. If the status code is 200, we extract the current temperature and wind speed of the JSON response. In the second example, post request authentication and error handling. For post request, we pass payload dictionary using the JSON parameter, which automatically sets the correct content type header. For API that require authentication, we include an unauthorization header containing a barrier token or API key. Robust error handling is critical when working with API. We use a try except block to catch timeout errors. HTTP errors using raise_4_ status, which automatically raises an expansion for XX and 5XX responses and connection failures. JSON handling in Python. JSON, which stands for JavaScript Object Notation, is a lightweight human-readable data format used by virtual or reset APIs. It maps directly to Python dictionaries and lists, making it very neutral and to work with in Python. The JSON model provides 4 functions: JSON dumps, function convert a Python dictionary to a JSON formatted string. JSON load pastes a JSON string back into a Python dictionary. JSON dump saves a dictionary to JSON file, and JSON load read a JSON file back to Python. The JSON model, here is the example that demonstrated. The second example is JSON handling pasting nested API responses. Real API responses are open nested structure. We use the gets method to safely navigate nested dictionaries, providing a default value in case a key is missing. In the example below, we extract a list of students from a data field of an API response, then loop through each student to display their name, score, and computed grade. A list of comprehension is used to extract all scores and calculate the average. The example below demonstrates the person nested API responses. File system automation with Python. Python OS short-tail and fat library model provide a comprehensive toolkit for automating file and folder operation. Common tasks include listing directories content, creating nested directories, checking for file existence, renaming, copying, moving, and deleting files. The fast library model provide a modern object-oriented approach to path handling and support pattern matching using glove dot function. And the first example is for use for file operation with OS and shorten, while the second example is for auto-organize download folder. The practical example demonstrates an automation script that sort file in download folder into subfolder by file type. The function defines a dictionary mapping category names to list of file extension. It then loops through all files, checks each file extension, and move into the appropriate subfolder, creating that folder first if it does not already exist. This type of script can save significant time when run regularly on a cluttered download directory. Automated report generation. Automated report generation. Python can generate structured CSV report automatically. The function shown here accepts a list of student name and score, tuple, computes a grade, and pass/fail status for each, and writes the result to a formatted CSV file, complete with a report header and today's date. That is the first example. While the second example is for automated report generation, email automation. Python SMTP library model enables automated email delivery. The function below composes a multi-part email message, attach a file such as the CSV report we just generated, and send it via Gmail's SMTP server using a secure TLS connection. This makes it possible to build fully automated reporting pipelines that generate, save, and deliver report without any manual intervention. Web scraping with beautiful solve. Web scraping is the process of programmatically extracting data from website. It is used when a website does not provide a formal API. Python's request library pages the HTML content of a page, and beautiful soup pastes that HTML to locate specific element. Before scraping any website, it is important to check with the site robot.txt file and terms of services to confirm that scraping is permitted. You should never scrape personal data without consent, and you must always add delays between requests to avoid overloading the server. In the basic example, we scrape the box.toscrape.com practice website, a site specifically designed to scraping exercises. We use find function to locate a single element and find _all function to retrieve multiple matching elements, such as all book title and prices on the page. On the second example, scraping for multiple pages. This advanced example demonstrates a scraping across pages. The function loops through a specified number of pages, constructing each URL using the page number. It pastes each page to extract book titles and prices, append them to a list, and critically adds 1 second delay between each request using time.sleep function to be respectful of the server. All collected data is then saved to a CSV file. Then scheduling and task automation. The schedule library allows Python script to run automatically at defined intervals or times without requiring a full task scheduler like cron. After installing it with pip, we define function for each automated task and register them using fluent scheduling syntax. In the example, we schedule a daily backup at 8 a.m., a weekly report every Monday at 9 a.m., and an API health check every 30 minutes. The script then enters an infinite loop calling a schedule run underscore pending every 60 seconds to trigger any do task. In the second example, that is sub-process model and automation-based practices. The sub-process model allows Python script to run shell command and other Python script programmatically. This is useful for chaining automated tasks together. Three important best practices for automation script are highlighted here. First, use the login model instead of print function statements. This writes stamped entries to a log file for a later review. Second, use argpaste to accept command line parameters, making script flexible and reusable. Third, never hard code API keys or password in your source code. Instead, store them in a .env file and load them at runtime using .env library. Complete project API plus automation workflow. This slide presents a complete end-to-end automation project that integrates all the skills from this model. The program fetches live currency exchange rate from public API, filters for key currencies including the Nigerian naira, British pound, euro, Japanese yen, Chinese yuan, and Ghanaian cedi. Save the result to a date stamp CSV report and log all action using login model. The function is first called immediately on startup, then scheduled to run automatically every 6 hours. A robust try/except block catches any API failures and logs the error rather than crashing the program. The pattern page process, save, schedule, log represent a complete professional automation workflow. Do and don'ts. This slide summarizes the best practices and critical mistakes to avoid when working with APIs, automation, and web scraping. You should always check HTTP status code before processing a response. Use the timeout parameter and the request to prevent script from hanging indefinitely. Store API keys in .env files and never hard code them in source code. Use raise_for status for clean error handling. Check a site robots.txt before scraping and time.sleep function between scraping requests. Log all automation activities using the login model. Use the schedule library for recurring tasks and always validate API data before use. Avoid hard coding API keys or password. Skipping error handling since API can and do fail. Scraping website that explicitly prohibits it. Sending hundreds of requests per second, which will result in your IP being blocked. Storing scrapped personal data without a legal basis. Assuming API responses always have the same structure. Running automation script without login. Ignoring API rate limits. Committing env files to JIT version control. Advanced skills summary. Let us summarize 3 pillars of advanced Python covered in this model. Under REST API, the request library is installed via pip. The 4 HTTP methods are get, post, put, and delete. Authentication is handled using bearer tokens or API keys in the request headers. JSON response are passed using response. JSON errors are handled using REST_for_status and timeout and retry strategy to prevent hanging requests. Under automation, the OS and short-tail model handle file operation. PathLive provide a modern path handling approach. Scripts can automatically organize file by type. CSV and Excel report can be generated programmatically. Email can be sent using SMTP library, and the schedule library manages recurrent task execution. Under web scraping, the request library page raw HTML pages, beautiful source pages, the HTML structure, find and find underscore all locates specific element. Multi-page scraping uses pagination logic, time slip, ensure polite request spacing, and scrapped data is saved to CSV for further analysis. Conclusion: this model has introduced three powerful advanced Python capability areas that dramatically extend what Python programmers can accomplish. REST API integration has shown how Python programs can connect to and consume data from virtually any online service, offering access to real-time data and cloud platform. File system automation and report generation have demonstrated Python power for eliminating repetitive manual work and improving productivity. Web scraping with beautiful stuff has added another dimension to Python data gathering capabilities, enabling extractions of structured information from website. Task scheduling ensures automation runs reliably without manual intervention. Together, this skill defines the competency level of a professional Python developer. Key takeaway: API connect you to the wall automation, save you time. Web scraping give you data. Together they make you a true Python professional. Thank you.